Then welcome everyone to the first edition of this architectural discussion about the Keptn Lifecycle Toolkit. Today we planned 3 different items in the agenda. We had the metric server, a new project that we created during the Christmas holiday in order to abstract this SLI and flow provider in terms of a generic metric expression in Kubernetes, so you can use it then in your HPA or any other KDA integration to scale your workload. And then we have application discovery. Instead of providing a Keptn application CRD to be able to automatically discover your application out of the box, so you don't need to provide any extra resource to your deployments, and also how we should configure the lifecycle toolkit via CRDs. So Moritz, do you want to kick us off with configuring the lifecycle toolkit in terms of CRDs?
Sure.
Thank you.
Let's see that I share the right thing here. Let's maybe start off with the initial ticket. This actually follow up already. So Thomas actually created this initial epic on how to, in the future at least, install and customize the toolkit. And I did some research on that, some initial research, and looked at other different operators that are out there in open source and checked what they're doing. And also checked the operator SDK, best practices, and so on. And basically, the result was that most people have a very simple Helm chart and then use CRDs to actually configure everything. And so this was my first revelation. I had a second research ticket to actually do that in the end and kind of do a proof of concept to kind of create a, let's call it Keptn config CRD for now, where you can configure stuff that's kind of generic for the KLT operator. So nothing specific in terms of Keptn apps or workloads in that sense, but general settings that are independent of your apps. So the thing that I actually used to test the whole thing is the hotel collector URL. And if we go to my POC pull request here, oh man, if I find the right stuff here. So we have a new API group, which is called options. So it's, let's open this here. And you'll see in here in the Keptn config spec, we have the auto collector URL, which is defined as a string. And then where is the samples? There. So yeah, this is super basic now. In the spec here, you would directly define your auto collector URL as a string with whatever URL you want to have there. And then you would apply this CRD as any other CRD into the namespace where the operator is running. And then with the classic operator stuff, so you have just another reconcile loop here. You have a controller for the Keptn config, which reconciles that configuration. And in here, it fetches the configuration first. There's some error handling. That we have a nice error message. Oh no, an info message actually. And then in here, we set the hotel collector URL inside the operator if it changed, and then requeue after some time to check again, basically. So the whole thing is basically built on the premise that we just do more of the same that we do already. We have lots of other CRDs for Keptn apps, workloads, and such, and configuration should just be another CRD to give us the option to kind of configure whatever we want in a generic way for the operator as well. So this was the basis for the research I did here. And the cool thing is that we can quite easily actually integrate that together into a Helm chart, so that the Helm chart itself can be super simple, and the only thing you kind of configure there is probably the namespace where you want to install the operator. And then everything else comes with the CRD basically. And for now, if I can find it in here, I actually already set up some files.
I had a small question to you, Moritz.
Sure.
I think that's great, but I was just wondering, while you were presenting the Keptn config CRD, and then it will probably happen that we could deal with several Keptn config. So I can have a Keptn config for namespace, I don't know, hotel demo, where I want to send it to a specific collector. Then I have another Keptn config because I wanted to send it somewhere else. So having a multi exporters or multi endpoints, because potentially you have several teams dealing with several toolings. So we also need to be aligned with that, I think.
Yeah, that's a good point actually. So for now, I actually have it in my research results here. I didn't think of that yet. So instead, I added some stuff here. I have a validation webhook that makes sure that there's only one Keptn config at any point in time. That's what I thought we need for now. But if you say it would make sense to have multiple configs for different namespaces or different apps, for example.
So if you take Fluentbit, for example, they have the notion of cluster config, and then they have the config. So cluster config will be widely for everything. And then you can have specific config that you define on one specific namespace, and then that config will be taken instead of the cluster one.
I would probably kind of rephrase that for KLT, since we don't really think about namespaces anywhere. I would say we have this generic Keptn config, and then anything else that's app specific, Keptn app specific, you would configure on the Keptn app resource instead. Maybe that's an idea we could follow up on. But yeah, definitely that's a good suggestion. Yeah. Cool. Any other questions already?
I'm still digesting the question from Henrik.
Yeah, before the question of Henrik, I had a question about, have you thought about config map instead of CRD?
Yes, I did, but in the end I decided to go with our own CRD, because we have the option to have conversions, for example, between API versions, and we can very nicely have also validation for the configuration in there. So we can have a separate validation webhook, and if you configure something in a wrong way, or somehow your configuration doesn't fit with any other config, we could immediately catch that and return a nice error message to the user. And that's something we couldn't do with config maps. We would need our own CRD for that.
Coming back to Henrik's topic, I think this is a much larger discussion, right? We want to basically, because what we do with the lifecycle toolkit, as you correctly said, Moritz, we're basically generating, or the idea is that we can generate traces across multiple stages. We can generate traces for individual deployments, but apps that span multiple stages in theory, right? That goes also across multiple namespaces if you are separating your stages with namespaces in a single cluster. And then the question is really, where does this data end up? The observability data that we create, should this data end up in one location, or do we really need to specify multiple locations? Do we need to separate it out?
Yeah. Speaking of OpenTelemetry, I think it does not make sense to configure different places, because we're using the hotel collector. And if you'd rather use the collector to multiplex the data across multiple observability providers.
Makes sense.
But I don't know if the collector can have logic to send only these traces to that.
Not yet. not yet. You have to send everything.
Maybe we should not solve a problem that we don't have yet, but it's
Yeah.
good to have this as in a thought.
Yeah, I mean, the auto collector URL I only took as an example here to implement my proof of concept, basically.
Yeah.
Something other to configure would be, for example, the version of our functions runtime, or maybe an allow and deny list for different pre-post deployment tasks and stuff like that. That's all stuff you could configure there, maybe.
Do you actually have a list of this, of the thoughts that you already had? Like what that's
just off the top of my mind. We started a list, but it's literally 2 things. So it's the functions runtime version and the auto collector URL for now, I think. Yeah, we already had some nice discussion in here, especially about the Helm chart in the end. So the whole plan for this is to basically dump down the Helm chart as far as possible, because our whole setup is based on Customize, and Customize doesn't play super well together with Helm. And we cannot or don't really want to switch off of Customize, because it helps us in many ways. Where Helm couldn't really fill the same hole for us. So yeah, the plan would be to have Customize and then a super simple Helm chart on top of that, where you can configure your namespace and your release name, normal Helm stuff, and everything else comes from CRDs.
The only thing that we cannot configure via CRD, but we need to do that in the Helm chart, is which modules should be deployed. For instance, we can have a flag to say also deploy the hotel collector. If this enabled, we also deploy the collector, otherwise we don't. Those type of things are still be possible having this dumb Helm chart with only this logic inside that, or not?
Yes, but the question is always how easy will it be to automate in the end? Because the whole point is not the whole point, but one big requirement we have is that most of the stuff is automated towards having an automated release. So as soon as we start with feature flagging whole resources with Helm values, that's something Customize cannot support, and we can't really inject that from Customize into the Helm chart.
No, I think this logic is built into the Helm chart directly, not via Customize.
Exactly, but that means we already have to have some form of custom logic that either injects those Helm expressions into the chart in the end,
I see.
if we actually generate it from Customize, or we need to kind of have a separate section that's not touched by Customize or something. The other option would be, but that's a long shot for now, I would say, having some form of management operator that actually deploys our KLT. And then that one would, again, with a CRD, you could configure there what you actually want to deploy, which modules, and then the management operator would take care to deploy the KLT in whatever configuration you want. But then again, that kind of speaks against best practices from the operator SDK, which says you shouldn't really manage an operator with another operator. But it's kind of tricky because operator SDK best practices has a framework for that, and we don't. No.
But why shouldn't you manage an operator with another operator?
That's the thing. The operator SDK has the OLM framework for that and takes care of that for you. But with KubeBuilder, you don't have that. Where is it?
And operator of operators is not an anti-pattern as far as I know.
Is not or no?
It's not.
Yeah. Only the operator SDK.
Yeah, because operator SDK has their own.
Exactly.
Because they are from Red Hat and they have the OLM.
Exactly.
But in general, I think this is not bad practice or an anti-pattern.
Yeah, in general, it would work probably. And we also get the benefit, for example, to have power over upgrading the operator and how that whole life cycle happens. And by operator, in this case, I mean the KLT.
I think it would be cool that we could automate the updates of the lifecycle toolkit.
Exactly.
Because then you could set up some things as a release channel or whatever, and could say I always want to stay at the last stable version and doing the updates automatically. This is what operators are for.
Yes. Yeah, so I think that's all I have to present. Yeah, I think that's basically all the results from my research so far.
Could you do me a favor and copy the URL into the chat?
Sure.
Thanks.
Yeah, to everyone, if you don't have some ideas right now on the spot, please go over the issue and comment afterwards. If you have suggestions or questions also.
Yeah, and then how to do the Helm chart in the end. This was kind of also part of the epic in the first place. We had kind of open questions about if we want to have the Helm chart in our main repo or if we want to split it into a separate one and use the chart releaser action from Helm to kind of handle releases of that automatically. I would say that's kind of a minor decision later on if we actually know when we actually know how to configure everything correctly. The Helm chart on top shouldn't be the biggest issue in this case after all. The configuration itself is the harder part of the whole thing. Yeah, so with this, I guess, does anybody have any more feedback or questions or anything else?
Not right now. I will make sure to mention this in the upcoming meetups we have. We have one in Linz next week and then one in Boston in 3 weeks. And just, I think we should, have you posted this already on the Slack channel or anywhere?
It was posted yesterday together with the announcement for this meeting, but not before, I think.
I think that's always good, like to maybe just, post it again. Maybe, Giovanni, are we posting this recording on the YouTube channel, I assume?
Yes, we are.
Yeah, then it's perfect. Yeah, then we can use this to promote it. Cool. But no other feedback right now on this, at least not from my side.
Then let's digest this offline and let's move to the second topic, maybe in the agenda. Thomas, do you want to show us what have you done so far with this proof of concept for a metric server?
Yes, I can.
Thanks.
Okay, just a second. Yes, this looks good. Okay, so I think it's always a good idea to share screen. And I just drawed a bit what I did here. So at first, why? So I will present a bit about Keptn metrics now. And the main idea of Keptn metrics was to get metrics or get things as decision base for the Kubernetes HPA. So for the horizontal pod autoscaler. And what we thought about was that we might need metrics more often in our clusters as for the Kubernetes HPA. So for instance, we need metrics for our Keptn lifecycle toolkit for evaluations. If someone doesn't use the Keptn lifecycle toolkit for such things, they might want to use metrics for Argo decisions, for Flagger decisions. and so on. And while creating this prototype, I thought it would be a good idea to simply create more or less an interface to have metrics as custom resources in the Kubernetes cluster. Therefore, at the moment, we designed two custom resource definitions. The one was the metric itself, and the second one is the metric provider, whereby the metric provider is implemented in the Keptn metrics operator. And this operator is responsible for, at first, watching the metrics resource, fetching the metrics from the observability provider, and write back the status to the metric resource, so that the data from the observability provider can be queried in the Kubernetes cluster itself. The second part we wrote, or I wrote for this, was the Keptn metrics adapter, and this is simply here for fetching for providing these metrics as custom metrics in Kubernetes. And this can be consumed by the Kubernetes horizontal pod autoscaler, and therefore everything is fine. So this was only the picture of it, but I think you want to see this a bit more in detail. I hope I shared the right screen. Yes, I did. Okay, so I have a very short example of this somewhere. So let's take this one. And what you see here is I have two resources here. I have Dynatrace metrics and I have a provider. So the example I'm showing here today is with Dynatrace metrics. If we take a closer look at Dynatrace, we see some kind of metrics in there. So we have our metrics blade, and we see some names of such metrics. So for instance, I have billing hosting unit assigned, I have an availability rate, and so on. I took some self-monitoring metrics for my playground here. And at first, the first thing you have to do is to create to set up a provider. The provider is defined in the is built in the metrics controller, and he knows if I have a provider called Dynatrace, I can he knows how to connect to Dynatrace. So for instance, I have a target server and I have a secret key which has the Dynatrace token in there, and using this data it can connect to Dynatrace. The second thing is I have my metrics. So, and for instance, I simply took some self-monitoring metrics in there and said, I have this query, I fetch this metric every 10 seconds and my source is Dynatrace. The same, and I can define as many metrics as I want. And the controller will fetch the metrics in this time frame. So let's take a look on how this looks like. So if I take a look on my metrics at the moment, I have none, and I can apply them. And I applied two metrics and the provider. I can get my metrics. I see that I have two metrics in there. And after some time, I also get the value there. So this, what's also possible is that you could mix the metrics between several providers. So you could also have a provider which is called Prometheus. The only thing which would change in this case is the source and the query. Otherwise, the custom resource would be exactly the same. Only the provider implemented in the metrics controller is okay. Okay, so fetch our metrics. So we could also say, okay, describe metrics and let's say aggregated data. And we also see that seconds ago, and the value is this one. So we can query them in Kubernetes as we want. But the second thing, which is more interesting and which was the main use case, was we wanted to consume them via the HPA, so via the Kubernetes horizontal pod autoscaler to take scaling decisions. And therefore, we could also say we want to get these things from the Kubernetes API. And this was the thing where it got really hard at some point in time, because it's not so easy to find out how this path looks like. So what you see here is that we are querying a custom metric, which is namespaced in the namespace default. And this is a funny thing, because here we are relating to our own metrics resource, which is residing in the default namespace. We see that it's of the kind metrics Keptn sh. The object name is built in dimensions, and the metric name is also built in dimensions. And this was a thing I had a very hard time with. And after some unfortunately, I can't get the metrics now, so the demo code is not with me today. I think, and I know what was happening here. I made an update, and this broke the thing. So in reality, normally you would get the response from the API server now. And you would also see some kind of JSON metadata. I think I posted this somewhere in a Slack channel. Just a second. Let's stick this one. Yes, so this looks like this. So this would look like this. So you would get you could list the metrics at some point in time, or all of the metrics you have. And the second thing yes, and this was the second thing I showed. I can yes, I will do this tomorrow in the community. Implementation wise, this is almost the same as we had in the evaluation controller of the lifecycle toolkit. The only thing which changed was that we have a new controller here. So for instance, I created a new matrix operator here. I created a new matrix adapter. And the operator has one controller. So this is the metric controller. And the logic of this is very, very small. So if you take a look here, this is the whole reconciliation logic. So this has around 120 lines. It simply watches yes, Henrik.
So if you want to create a new metric provider, what would be the journey? You have to recompile the entire operator, or is the way of enhancing the operator with an extra? No, you have to recompile everything.
Yes, so the idea was that to take a similar approach than other projects do, such as Telegraph, or I think even Keda does the same way. And to simply create a simple provider which simply fetches metrics. So if you take a look here, this is the Dynatrace provider. This has around 100.
Do you think we can do like a custom, like a deliver with Prometheus and Dynatrace, like a Keda is doing it, the HTTP metric provider, where you just define an endpoint, the post, the request, the headers, how to retrieve the metric. So then the community don't have to build a basic provider just for querying an API. If we have like the HTTP generic metric provider, I think that will help a lot for our community.
If there is something else, we could build it. So the only thing I wanted to show here is that the logic for evaluating some metrics is not very much in our thing here. So it was around 40 lines of code. If we want to create another more generic metric provider, if such thing exists for the or if this can be used, yes, it would totally make sense. The simple idea of all of this was that you simply have to create. This is more or less a unification of metrics inside of a Kubernetes cluster. So when you think of Keptn before, we had an SLI provider for each observability solution, and the SLI providers were not very slim, to be honest. In our case, and this is thought one step forward, we could say we have a way to fetch metrics in a generic way, but we could, for instance, create an SLO object which references to these metrics and simply compares it against thresholds. And I think this would be a very, very mighty tool, to be honest. So because everything we're doing with SLOs and so on is simply, in the end, they are metrics, I think. Okay, so at the moment implemented, this is Dynatrace and Prometheus. So the two things we implemented also in the evaluation controller of the lifecycle toolkit. So the implementation is the same. And in the future, it could also be a plan to use this metrics interface also for the Keptn evaluations. Therefore, the Keptn evaluations would also work without specific providers, but use this metrics provider. Yes, and I think that's it almost. So for the metrics, yes, the second component is the metrics adapter. This is the one for the HPA. This is also a very simple thing, mostly boilerplate from another thing. The only thing I had to write was one provider, and this is the first interface to our own metrics interface, which says, yes, I've go to the object metrics, Keptn SH metrics, and take what you get, and represent this as a value. But I think this is a thing which can be, which you can easily see in the pull request. Yes, this would be it from my side at the moment. So I don't know if Christian is here. I showed him yesterday how the HPA things work.
It was working. I can.
Unfortunately, I broke the demo today. But as I said, I will try to make it work for tomorrow's community meeting. So, spoiler, tomorrow it will work.
I got a couple of questions first. Thanks for this. And some of these questions might be stupid because of my lack of knowledge on this. But my first question is, in your metric definition, you specify a frequency. I think you had 10 seconds. Yes. Right? That means every 10 seconds you're reaching out to that API, pulling the data in from the last 10 seconds, I assume, right?
I'm only pulling the current metric.
Okay, but you always have to specify a time frame. That means in this case you're just using what time frame do you use to pull the data? Just the interval, or
it's the current one. So the last one.
Okay, the last value. Okay, and
yes.
Then you're
I think these are some more specific things. Yes.
Okay, and here's why my really lack of knowledge. You're writing this back to the metrics object. That means yes. You're writing a value every 10 seconds. Where does this just override the status, or does Kubernetes also keep a history? No, because otherwise you would basically end up with another database with a lot of metrics. Okay, I just wanted to make sure that we're not building another time series database here and misusing Kubernetes for this.
No, at the moment this is implemented in a very simple way. So we are not taking care about about more data at once. So as you said, the time frame. These are things, for instance, which could be held in an SLO object to keep a list of the last 10 values or whatever.
But do you have to query every 10 seconds? I mean, because if you look
No,
the
I
logic,
could also query every 30 seconds.
No, I mean, I was meaning because if you look at the logic of the adapter, you define a metric, and then the metric adapter is the dictionary to translate how to collect the data back to the endpoint. And initially, when you present it, I say, "Oh, this is it's amazing because it's a universal adapter for metrics API." So basically, I was expecting that when I need that metric from a Kubernetes perspective, then it reached out to the metric operator, and the metric operator at that moment says, "Oh, you need the metric. I'm going to pull it out." So basically, you don't have that polling sequence that has to get the metric every 10 seconds.
Yes, but this would be synchronously more or less. And this could get really, this could lead to the same situation, because when you are using the Kubernetes HPA, this will also query every, let's say, 30 seconds.
That's true.
And therefore, this would lead to exactly the same situation, and could get even worse. So, for instance, if you are querying the object more often, then you might have lots of queries against the observability provider API if you are not using caching. And this was also the reason why I chose exactly this architecture, to say I want to specify the metrics as a custom resource in a cloud native way, query it every n seconds, and simply consume it when I need it. So, for instance, I could use this metric I have for the Kubernetes HPA, but I could also use it for Argo. But because it's already there, and it wouldn't cause more queries.
But are this been designed as well for validation tasks? Let's say I'm doing a post deployment check with the tests, and then I want to have something that pull out metrics to see if my tests were successful. Is this component going to be used for that as well, or just for the HPA scenario?
No, this could also be used for evaluation purposes. This was the reason why we pulled this out into a separate component.
Okay, and how in that case at the moment you define a like a frequency when how frequent you want to collect the metric, but is this the way to say, oh, I want to give me the data between I don't know 1 and 115?
I think this is a thing which we have to define.
Okay.
So at the moment, as I said, this is defined in a very simple way.
Okay.
And we are only storing the last metric.
Okay. But then again, the metrics provider actually has that functionality already. So if you define your query correctly, you can have that anyways. Just not configurable every time. So you could have, for example, I don't know, the moving average with a time window of whatever, 10 minutes. You just define that in your metrics query, and then you have it.
Okay.
And something like this has not been built yet. So nobody else has tried to do something similar to this in the Kubernetes, in the CNCF space.
Keda is doing.
So in the end, I found out that Keda is doing a very similar thing, but they are using it only for autoscaling.
Yeah, but they're doing this similar stuff. Yeah.
So that means they also provide different data providers, or
Yes. I also thought about using their providers for us, because they're already there.
Then the question is, why would we build something on our own and not extend what they have and then use it as a default component that we can also leverage?
This is a thing we have to look at, because Keda at the moment has a clear scope on autoscaling, and they don't want to be a matrix provider as far as I saw. And in our case, as we are more related to the whole deployment, to the whole delivery domain and so on, I think it would make sense to have one metric server which does this. So what I also thought of was to create a generic provider for our metric server for Keda, and then they could get rid of their integrations.
Beware, because there are a lot of things with jobs. They also have lots of adapters that go pull out data from different queues for their jobs use case as well.
But yes, in this it would make sense to take a closer look at Keda.
one question that I still have is on the scalability side, because right now the more metric CRDs we have, the more load we generate. Is something similar in Keptn?
I think this depends. So I think it depends on how often you query the data.
Yeah, also true.
And how
with
many
the interval.
CRDs you have. So if you query a lot of CRDs every 1 or 2 minutes, then the CRDs themselves are not the problem. So I created a test with config maps at some time ago. I think I created 40,000 config maps and had no problem.
Okay.
And afterwards, it got boring for me.
I had a note. Maybe it's Prometheus is becoming like a standard, or OpenTelemetry metric is becoming like a standard. Why don't we expose back the metrics in those formats and then store it in Prometheus, and then the only adapter that we rely on is Prometheus, or maybe OpenTelemetry metrics in the future, instead of being all that?
There is an idea to expose the metrics we have as objects as Prometheus metrics, because this would be a thing where we could integrate in almost every tool, even in Keda or in Argo or in Flux. So, and this the nice thing is that this wouldn't even be much effort, because it's really easy to expose things, so to expose Prometheus metrics, as we all know. Yesterday, I think I talked to Christian, and we also said we could provide an API which simply gives you back metrics. So this could be kind of and I'm not sure how this is called in English, but a Drehscheibe for metrics. Because at the moment it's very easy to ingest metrics into different observability providers, but it's really hard to get them out. And this could be one value the Keptn metrics could bring.
That's also the value of the collector.
Yes.
So what you're suggesting, Hendrik, is that besides showing this metric inside Kubernetes via CRDs, we also create a scraping endpoint that exposes this via in form of Prometheus and send them to the collector.
Or basically we naturally push. We have the options to when we deploy it to have naturally the exporter enabled. So which means every time we provide metrics, we export it to a destination.
Mm-hmm. Because I find it a bit weird. Do we need that? Because we are extracting metrics from the observability provider. So why do we need to push them again back?
Because at the end we are like a dictionary, because we have like Keda, because Keda is doing it only for HPA, like mentioned, but here we're doing for more larger scenarios. So we could be like a bridge between different providers, and then at the end we collect the metrics and then we expose them back.
Okay, I get your point. Yeah, I get your point. Thank you.
And just
this was one of the reasons why I didn't want to write the Keda provider. Mm-hmm. So why I wanted to have why it's a good idea to have this in a separate thing and make it queryable by different things.
Basically, it can be used by Keda for auto-scaling purposes. Yes. It can be used by HPA. We can use it in the Keptn Lifecycle Toolkit for SLO evaluations. One thing which came to my mind, I think in Dynatrace it's possible to have this predictive analysis. So looking a little bit in the future, so you can do proactive scaling for your deployments in HPA, for instance. Mm-hmm. So if we're thinking, hey, in 10 minutes, there will be more workload, then you can really proactively scale something up. And in the SLO evaluation, then you can have multiple data sources, which is nice. So you can pull in data from, I don't know, Datadog, Prometheus, or whatever down a trace, and having combined SLO there. And not only having an SLO based on one SLI provider. So it's really generic.
And from my understanding, so I have a metric in Prometheus right now, CPU. It gets ingested into my observability tool, let's say Dynatrace. Then we pull it out again. If we specify it as a CRD, that means for the same metric I have in Prometheus initially, where I have a different name in Dynatrace, then I get a third name. Is this kind of what it is? And then I re-ingest it.
No, you don't need to re-ingest it.
You don't need to ingest it.
You can if you want to have a fourth name.
I know, no, but the default setting might be that the observability platform ingests all of the metrics, right? I know with Dynatrace you have to annotate what you want, but maybe you say get it. I want to figure out what this means from an end user perspective. Right, this is just I'm trying to figure this out. How would this look like in a real life scenario?
So in fact, if I would be an end user, I would take a look on my observability platform, such as Dynatrace, would try to find out how the metric is named, would specify this metric on the other side, because that's the same as we are doing in Keptn at the moment. So I specify my metrics object, and that's it. Where the data comes in to Dynatrace, I think that's not the problem of the end user, right?
No, you're right. Yeah. It's just like the special situation with Prometheus being most likely the source of 80 to 90% of all metrics on Kubernetes. Then getting this into your platform, which could be Dynatrace, Datadog, whatever, and then we are defining it again that we want to have it back for our use cases.
That's why I was wondering as well if instead of being our own adapter, we do everything in a Prometheus format and we only use the official Prometheus adapter for HPA, which means whatever we have, we expose it back in Prometheus, and then at the moment, a lot of people are deploying the Prometheus adapter, which is the only one. Oh no, there's other ones, but the most popular one for sure. So then you can use it for HPA or for other scenarios. But at the end, we are the bridge, similar to Keptn, but then we expose back to Prometheus. I mean, that's just pure suggestions again.
So, but in the end, you have to store the data somewhere. So even if you use Prometheus as an adapter and so on, you would have to query an external system, more or less. Or even you could write your data to a Prometheus in your cluster, or you could use an external one. And in our way, you could use the thing once, and you could specify it once and use it 1,000 times. So the same metric. In an adapter way, if you are not dealing too much with caching, you would query it anytime. The second thing is always the problem, what's happening if your Prometheus server is not available. And especially for auto-scaling decisions, to be honest, I don't want to know what's happening there. And therefore, I think it's a good idea to have these metrics there where they are consumed, so in the cluster. Because in our case, we are scaling on the last known metric. And if the metric server outside is not there, we are scaling on the last known metric, more or less. So I think for some decisions it's a good idea to have the metrics in the cluster and not outside of it. And this is a very cheap way to get to it, because you don't need a separate data store.
But you agree, Thomas, that we still need to do like a metric provider? I mean, I don't know, I don't remember the terms in Keptn, but we need to have a way of pushing our metrics back to Keda. So then the HPA scenario will be managed by Keda.
For HPA, we would for Keda we might even need another provider. So we could expose our data as Prometheus exports, or we could expose some kind of API.
Isn't it possible in Keda to just consume with a generic metrics API scaler to say pointed towards the Kubernetes API endpoint where the metrics are being stored and say just extract from the JSON path the value?
Yeah, there's an HTTP HTTP generic, so then you can just define your request, and then it's going to pull out the metrics from that request.
Might also work.
Cool. Next steps on this?
Giovanni?
Split the proof of concept of Thomas into implementation ticket, so everyone can start work on the implementation. Plus having some feature flag to decide if we should expose also these metric results in form of only CRDs or also as a Prometheus object.
I mean, in the metrics server, wouldn't it be a big deal just to expose it anyway as in Prometheus metrics? I mean, it's
yes, but I think it would be cooler as a feature flag. I could work on this tomorrow.
Now, I would rather go with a feature flag because I'm afraid that many users will enable the scraping all Prometheus endpoint that you find, and you ingest your data twice in the observability platform. So I would rather start more conservative and keep it behind the feature flag, just to be safe on the safe side. But then we can, remove the feature flag in the future if we see that users want that behavior as default one. Your opinion on that?
Why don't we do it from an OpenTelemetry collector perspective, where we push everything in OpenTelemetry, and then the collector will be the one that will filter out or drop the metrics that won't be pushed back to the observability backend.
Can the collector do that?
You have a metric transform, so you can transform. You can say for metrics with this pattern, a drop or add label or modify whatever you want. You have that. It's a transform processor.
But if you think about our customers on the Dynatrace side with the one agent operator where they scrap everything, or is this not the case anyway because they need to annotate the metrics?
You need to annotate, your deployment with the port and endpoint.
And also, even if they put annotation, it will be annotated on the operator of Keptn or the metric operator. And that will be taking the context of the pod of the namespace of that specific workload. So then it will be indexed in a very strange way, Dynatrace. So it's not going to be very efficient. I think it makes more sense that if we want to export from the metric operator, that we add the right context. So, we pulled out this information from this host, this tenant, whatever, and we add that label in the OpenTelemetry metric extractor. And then we can forward it back to the collector, and then the collector will send it back to Dynatrace or any others with the right context. Because otherwise, if the operator of Dynatrace collect from the annotation perspective, it will just put a mess.
From the community, I see David, Rashid, Shardul, and Roland. Do you have an opinion on this? To use Prometheus, Datadog, New Relic, Dynatrace as observability platform, or anything else? Prometheus. And do you think the collector strategy to work fine for you in order to don't export this metrics twice to your observability platform? Meanwhile, we are waiting for the writing answer. Henrik, in order to write the answer, I think for testing it could be good. Nope, I haven't used Prometheus. Oh, okay. I have a question about the collector. Do you need to compile your own version of the collector if you want to have this transformation?
Nope. The hotel collector contrib, the latest version, if you go to the contrib repo, has all those processors included.
Okay. So I would say having those deny list in the collector makes sense to me as well. Then I will create some of these issues in the next days. Hopefully there will be also many good first issues, so the community can also support us without much knowledge about this topic. Any further points for this?
No, but
Andy.
I want to say thank you, Thomas. I
Mhm.
think it's a cool project.
Yep, same here.
Thank you.
Yeah, same thing. I love it.
Okay. Then bye-bye, Henrik. Then Flo, I guess the stage is yours.
All right. Just give me a second. Do you see my screen?
It's big.
Is it large enough? Okay. Yeah, so I would like to present and discuss the application discovery epic. So Andre provided the initial description of this whole story here. The bottom line, why do we want to have to do this? Essentially, it's to lower the entrance barrier of using the lifecycle toolkit further still, because right now, for example, if you would have a multi-service application consisting of several deployments that are part of the same application, you would still need to, as a user, define and write your own Keptn app resource, because during the creation of the workload instances, those will then look for a matching Keptn app, and if there is nothing matching, then the workloads won't be able to get deployed. And now, for example, if we think about existing applications in Kubernetes where you have all your manifests, and ideally with all the Kubernetes recommended labels that we use, like the name, part of, component, and version, then it would be cool to just have the operator running in your cluster, but without any further changes to your application manifests. Already make use of the lifecycle toolkit and initially or immediately get the DORA matrix that we provide via the toolkit, or also the traceability features with the open telemetry traces, right? And yeah, so that's the goal for the end user. And here Andre already formulated a couple of initial open questions, which I would like to go through after I've presented my approach. So first of all, or maybe, yeah, what is the best time to generate the Keptn app resource? I think we have to talk about that for a second to understand the complete concept. Because right now, what we're doing is when we reach the webhook, when the webhook is being called for a pod that is about to be scheduled, so the pod for one of our deployments, for example, if it will check whether the labels are present, the labels that we rely on, and if it's part of a Keptn application and all the names are there, the labels or annotations, it will create the workload instance referring to the app. And here is the question: where do we want to actually create this Keptn app that the workloads will refer to? So for a single service application where we only have one deployment, right now, you should now see the code of the webhook. Right now, what we're doing is, if we have the required annotations, but there is no app annotation, so no app name the pod is referring to. Here we know that we have a single deployment application or a single service application and automatically create the app that we refer to. But in the case of multi-service applications, this is a little bit trickier because also at the time when the webhook is called, we might not even have all the deployments that refer to the app, because they might come in at a later point in time, and therefore this would increase the complexity of the webhook quite a bit if we would at this point try to poll for some time for further pods coming in referring to the same app. And yeah, for the webhook, this is definitely way too complex and error prone because this should be a rather simple component. So that kind of rules out the first approach that was suggested in the initial ticket here. And that's why I decided to do the proof of concept with the second approach, which I'm going to show you in more detail now, which is that the webhook, of course, again, checks for the required annotations and checks if the app annotation is there. But after that, it doesn't create the Keptn app. So regardless if it's a single service application or a multi-service application, but rather it creates a Keptn app creation request, which means that this is kind of a promise for the operators that reconcile the workload instances and the tasks and whatnot, and of course the Keptn app version, that there will be a Keptn app resource eventually when all of these resources are being reconciled, meaning that the workload instances especially are being handled. And yeah, and this already simplifies the webhook logic that we have right now, because here we don't need the distinction between a single service or a multi-service application anymore. So we just make sure that all the labels are set or annotations, and then promise on the quotes that the app will be there, right? And then that opens the window for a couple of other interesting questions, which I already briefly touched upon, namely that, for example, how do we handle the case where we don't apply everything at once, but for example, it takes some time until all the deployments of our applications are deployed and available in our cluster. And here, my initial idea for this proof of concept was to introduce discovery deadline seconds property in the Keptn app creation request, meaning that for a certain amount of time that can be configured with that here. So by default, it's right now 30 seconds. During this time, we keep trying and see whether a user-defined application will come in, right? So if the user itself creates a Keptn app with all the workloads that should be contained in this app is there, then of course we wouldn't want to overwrite anything here or create the app custom resource on our own, because we, in this case, we would like to use what the user has provided, right? But if after that time, maybe I can already go to the controller of this. But if we, after this time, don't find anything defined by the user, then we know, okay, we have the promise that we will create a Keptn app, and now we have to deliver on that. So at this time, we create the Keptn app with the controller automatically. And then the nice side effect of this is that during this discovery deadline, so this 30 seconds period, for example, it is very likely that all the other deployments that are part of our app or are going to be part of our app are already also added to the cluster. Because if we think of the application of a Helm chart, it might take a couple of seconds depending on how many manifests you have in there. But I think after 30 seconds, for example, we might already be on the safe side. But of course, this is a very individual value. And if you really apply your manifests manually one by one, then of course, you might want to increase this deadline discovery period. So much for that. And then, yeah, then what happens then is, if we have not found an app, at this point, we are going to create it. And let's go to the creation. Sorry, I forgot one crucial thing. So of course, before we create the actual app custom resource, we at this point would also like to know which workloads do we have here that reference our app. So we retrieve that. So here in this proof of concept, I added the index on the app name of the spec, just to be able to filter the list of the Keptn workloads a little bit more efficiently. So we retrieve all of those that refer to that particular app that we're going to create. And then we basically just create the Keptn app resource. Of course, the pre-post tasks and evaluations are going to be empty at this point because we wouldn't want to block any deployment due to some task that we add here. So this is going to be empty. And then we are adding all the workloads that we have found at this point in time, right? And then afterwards, we create the Keptn app custom resource. And from there on, it's basically exactly the same logic that we had previously. So the creation of the Keptn app will result in the creation of a Keptn app version. And the version keyword is then something that I would also like to further discuss. And then everything will be reconciled. And after that has happened, you are going to be able to view all the metrics and the traces if you have configured your OpenTelemetry collector to gather all this data. And yeah, words.
Just a short question from my understanding. So this app creation request is the promise you mentioned earlier, right? So
exactly,
with that,
yeah.
Okay, so with that you save that you actually need to create the thing. Okay, cool.
Exactly, yeah.
And then this timeout, the 30 seconds, where's that configured now?
Right now, this is hard coded in the webhook, but of course, this could then also be maybe a interesting value to be configured via custom resource, for example.
Yeah, I was thinking that would be a cool thing to configure with my stuff then.
Exactly that.
Cool, thanks.
All right. Yeah, so maybe let's briefly talk about the version, because this I found to be a bit tricky to decide on, because we don't have any explicit app version set in our application discovery case. So right now in this proof of concept, I've hard-coded it to 1.0.0, for example, but this will be something that we maybe have to discuss later and think about, because I think one idea was also to derive the version from the versions of the workloads that we're deploying, but I'm not sure how to best approach this. So if you can already keep this in the back of your head, and if someone has a suggestion on that, then I'm open to new ideas. But right now in this proof of concept, it's hard coded to this particular version, and from there on, new revisions are going to be created if something changes. All right, and then the second conceptual question I had here was, what happens, for example, if we think about our potato head and we deploy our initial version and we automatically create the Keptn app, and then, for example, the potato head grows a third arm, for example. So we add a new deployment to our existing application. So here's the question: should we support that, or should this result in a new version of the application or in a new revision? So right now, I believe, but that's just my opinion, we should definitely support this, because of course, if we say that the initial entry barrier for using the KLT should be minimal as possible, and then we somehow block new deployments from being deployed due to the app that we created previously, not including this particular deployment, then I think this wouldn't be a good user experience. So we shouldn't block anything from being deployed in that case if we are doing this automatic creation. So that's why I right now implemented it in a way that if a new deployment is discovered, then it's added to the Keptn app custom resource, and with the Keptn application restartability already been merged and in place, this will result in a new revision of that particular app version. And then basically this added deployment will be reconciled. All the other workloads will already be in the reconciled state if the versions of those have not been changed in the meantime. Yeah, sure.
You said it will result in a new revision. Shouldn't it result in a new version if we, for example, add a new workload? I would expect that should result in a new version, not a revision. Revision is just a minor update, just due to restarting the post-deployment checks. But in this case, I would expect a new version, not a new revision.
Yeah, would maybe also be a possibility. So right now I kind of implemented both approaches just to see how it feels. So here, sorry. There. Why can't I make it smaller? Okay. Yeah, maybe for presentation, this was purely intentional. So right now I've implemented it such that when a new deployment is being added, or a new workload, then that will create a new revision of the app. But if one of the versions of the existing workloads changes, then that will lead to increase in the app version. So not necessarily the most logic thing, but I just wanted to see how it behaved in those two scenarios. But of course, creating a new version for a new workload coming in would definitely also make sense, I think.
Please, Moritz.
And this is all happening all the time, right? Not only inside of the 30 seconds. So at any point in time, I can add more workloads to my Keptn app as long as I know the name.
Exactly, yeah. So right now this is, you can see here when it's created, then it keeps reconciling every 10 seconds, just, basically to support and make sure that we support the creation of additional workloads and not block anything here.
The issue here that I see though is you're always growing, but you're never able to delete a service.
Let me see how I've implemented it. I think I implemented it in a way that we can also remove it from the.
No,
I'm not 100% sure, but
with what I mean is I deploy version 1 of my application and it contains head, left arm, and left leg. Then I deploy a new version of my application, and now I have also the right arm and right leg, together with the left leg and right leg and left arm. Then I said, okay, the third version instead is just right arm, right leg, head. No left leg and arm. I cannot do that now.
Yeah, for that, I think you would have to manually. Yeah, here you would have to manually work with the Keptn app resource.
I'm also not personally a fan of creating, if I understand it correctly, the webhook creates the Keptn app creation request CRD always if a new pod comes in. And the handling if the Keptn app already exists is handled in the reconcile loop of the Keptn app creation request reconciler. Do we basically want to, because we had a nice scenario where the user applies the manifest and the Keptn app, and this was one path. I thought we want to support, we do not want to touch this part, but we want to support also additional use case where the Keptn app is not added. I think now we basically squash together these two parts by always checking if the Keptn app, not checking if the Keptn app exists in the webhook, or maybe I do not understand it completely.
So
correctly.
I would say that the current implementation makes more sense to me because we are decoupling the creation of the Keptn app in a asynchronous way. Before, instead, we have this logic in the webhook that was able to also create this Keptn app instead of doing that asynchronously. Do I answer your question?
Kinda, but I need to think it through maybe a little bit also.
I agree with Giovanni, actually. Like it makes sense. We are basically reusing all the code that we already have and just adding a new scenario on top of that, basically, but we can reuse all the rest because all the rest of the reconciliation up until the point where you actually create the Keptn app automatically is the same.
Exactly, yeah.
So that's the big benefit.
I'm just wondering if it doesn't add too much complexity for the scenario where the user has created the Keptn app and has applied it also with the manifest. This is very straightforward scenario. And I don't know, from my perspective, if the Keptn app is there, the app creation request basically shouldn't be there or should be there just for a really small amount of time and do nothing.
I think
that's what the discovery deadline is for. So basically what happens then is the webhook again. So this is the same for regardless if the app will be created automatically or if it's created by the user. So it will say, here's the app creation request, make sure that this exists. And then the app creation controller will then notice that we already have a user-defined app, and then it will delete the creation request, for example, and then that's it pretty much for this component. So from a user perspective, basically nothing changes here. Yeah.
And I like that we are now getting rid of a direct API call from the webhook towards the Kube API, because webhook should be super fast.
We aren't, because we're not creating Keptn app, but Keptn app creation request.
Yeah, but right now we also check if the app already exists or not in the webhook, and now we get rid of this API call. So net one less API call per webhook invocation.
And coming back to the scenario where we want to delete the workload from the Keptn app, I would actually say that it's fine to draw the line somewhere there in terms of automatic out-of-the-box behavior. First, to save complexity on our side, and also I feel like that's not necessarily a kind of quick start scenario that we need to support. It's so, like, you're so deep in customization already in this case that you can or should actually take your Keptn app and make it explicit, and then you can have all the configuration you want.
And to me, it's not also a hard limitation, because since we do everything automatically, if your application does not contain anymore your left leg, you just delete your workload, and then it's totally fine for us.
Yeah, exactly. So in this whole auto discovery use case, removing the workload would be to not deploy apply the deployment anymore, I think. And then, as Moritz said, for any further customization, then you're already at this point where you have to configure the Keptn custom resources yourselves.
But then again, if you actually delete the workload or the deployment underneath, you will have a mismatch between what is configured in the Keptn app that we created and the actual state in the cluster.
Yeah,
I
but
agree with Mo.
But you have a Keptn app which is basically ready. You just have to fix that little thing. It's way less work than if you had to do everything from scratch.
I personally do not think that we need to support this kind of scenario, because that's so complex already for us that the user is really should be willing to create its own Keptn app, because we're thinking about this scenario just to kind of apply the manifest that I have without any changes. And normally, if you want to again play with the manifest, you should really go the path that you create your own Keptn app and apply it, not let everything on auto discovery. That should be just the simplest, clearest path, at least from my perspective. That
Yeah, that's what I meant as well. Yeah.
You just apply the manifest and we will create the app, but you have no limitation that you need to apply them in 30 seconds. You are not able to delete nor add new workloads, just to have an app and have the metrics out of the box of your application. If you want more, you can always do some additional work and have the full potential there.
I'd be actually fine with adding, like, automatically adding stuff to the Keptn app. Because there's nothing else we can do anyways. If it's the same Keptn app name, the only possible thing to do is to add it to this one or to not add it anywhere. Because we can't create the same one with a new, the same one with the same name anyways. Right?
Yeah.
The only thing left to discuss, I think now, is the version. We didn't touch that yet. And for me, I will keep a non-semantic version, just to don't give any apparent promise to users that we are able to evolve correctly the version. I would rather compute an hash on top of the manifests, just to convey more the message that this is automatically generated.
Why not just have an incrementing number?
Also, a revision 1, 2, 3 like Helm does.
Yeah, I would still go with the version, and we increment the version and not the revision, but still just have it as a single-digit number.
Mm-hmm.
Why don't we use generation? We already have it, and by each update of the Keptn app resource, it's bumped automatically, and we can use it as a version.
So you mean the version stays at 100 and you just bump the generation?
It does not work.
No, I mean that the version will be the same value as the generation.
Would the generation change if I
No.
change something like a pre-check?
The generation always changes as soon as you modify something in the spec. Yeah.
I will not keep it as binded to the generation because
Yeah. I could have the same exact app and just want to change the pre-check I do to it. And that's not a different version.
True.
Yeah.
but also, yeah, either a hash or an incrementive number. The incremental part is the hard part because then you need to fetch what was the last one. Where the hash, you don't need previous knowledge, but I don't think this is a big problem.
If I make a mistake and then I go back to before, would I expect to have a new version or would I expect to have the same version as before? I guess that's how we decide which one, if incremental or hash.
Are we talking about complete random hash generation or hash from the workload versions or workload names plus versions?
I thought that one, yeah.
Based on the spec of the app version. On the spec field, I mean. On your question, Anna, I have no idea. Given your expertise, Thomas and Christian, what would you think is the best?
I would count out.
I mean, just single incremental number.
But I'm not sure if it is good if the version field in the app version is not a semantic version. There we have to take a closer look on the code because I know that I'm not sure if we are using
in the
specific
workload
things.
instance controller we are using a semantic version. Yeah, so that we might need to consider.
Because we are using semantic versions, I think they're on the app level as far as I can remember. But otherwise, we could invent some things as a semantic version for this. However, this could look like. So we could use 000 and a hash behind it, or a counter behind it.
Don't we abandon?
I think that's similar as it is in Go mods if they have no version, right?
Yeah, it does 000-hash.
So this would be one possibility, or 000 and a counter. Because I think this would also be a version which no one would ever assign. Same as last words.
Why we
Mr.
are using
Dash?
semantic convention parsing in workload instance?
To find the matching application for a workload, I think.
But why we don't just take the string that we get for version and we just look?
I think because we also want to retrieve the latest application. I think somewhere we have
use it to
a concept of ordering of versions there.
Mm.
To make
I
sure
think
we're
we are
referring to
using
the
we are
latest.
using it to I think we are using it to find to get the latest version.
Yeah.
Okay.
Because there we had a really ugly bug in one of the early stages of the lifecycle toolkit. Because I think it always matched when some application had the workload instance in there, and we wanted always to ensure that the last one has it in there when we bind it. Or similar.
Or does Flux or Argo provide the commit hash with which they have been doing the
This depends.
synchronization?
I'm not sure if they provide it somewhere in the annotations and so on. I also know that Argo would provide either the commit hash or the tag if it is a Helm chart.
Mm. Yeah, it would be cool to maybe just do this discovery also of the version automatically if you're using Argo, Flux, Wavework, or any GitOps tool. Fetch the commit and use that as a hash, as a version. Or if we don't find anything, go with 000 dash incremented if number.
I think this would be the cleanest way at the moment.
So that means that Argo, for example, adds an annotation to everything it applies. Or
I'm not really sure, so I don't think so, to be honest.
But anyway, this is a discussion for really fine-grained point. We can also implement with just a counter, and we can refine it in the future. And we said instead of having this 000 dash counter, we will use dash hash or whatsoever. The important part here is
after some time, the users will switch to their own app definition.
yes, exactly.
And this should only be for initial things, so we can have an opinion on it, and it should not interfere with something. But in this case,
yeah, the only requirement that we need to have is the version must be a semantic versioning, and that's it.
Yes.
Any point left open, Flo, for this?
no, I think just going through my list, but I think maybe one thing that's interesting if we consider the spans, because I think that was also a question in the research ticket, whether we break anything regarding to the spans. So we don't break anything, but maybe one thing that's interesting to consider when we talk about the additional deployments after we have already reconciled app version, how this will look like. So here in the initial trace, we have deployed all the services that we had at this point in time. So we had the entry, the head, and so on. And after that has been reconciled, I have added a third leg or a third arm to the potato. And in that case, a new span will be created with only the the new addition being included in the trace, because everything else has already been reconciled at this point. So therefore, only the new workloads will be included in this new parent span here. So that's something to keep in mind, because we have a new span ID for the new revision that has been created here.
That makes sense to me.
Yeah.
I have one question though. Do you still have the trace context of the previous trace?
Of the previous trace, it should be in the annotation of the app revision.
So you would be able to also, if you want to see the old trace context, because I would like this shot to me link, OpenTelemetry link, where you can add as a link the old trace that did the first deployment.
Yeah, so here we might refine the whole application restart epic to link to the same trace ID for several revisions, I think.
No, it's fine that you create different traces, but OpenTelemetry also supports links. Basically, when you create one, it says, I also link another trace, and I can jump then to the other trace if I want. So you can still keep a bit of context between two different traces.
Yeah, so that should be possible, I think, because we do have the previous revision of the application version.
Great.
All right, and I think with that, I have touched on all the points I wanted to discuss today.
Perfect. Any last topics? Otherwise, we cover everything that we planned. Tomorrow on the community meeting, we will also briefly present again these results, but more on the user point of view, what will happen for user using these new features and not so technical discussions. And yeah, thanks everyone for your cool work. Hopefully we will have more implementation tickets for everyone to work on, really make a product out of this proof of concept. Thank everyone and have a great day. See you tomorrow. Bye bye.
Thank you. Bye.
See you.
Bye bye.
Ciao.